morning, everybody. My name is Razia Haider, and my research topic is peer-to-peer system and wireless sensor network, and my tutor is Professor Febbraio. During the second year of my PhD, the main objective of my research activity was to propose and implement a probabilistic solution for the RFID data management system. We mainly focus on the following data management issues in the RFID-based location system, which are the data acquisition and online filtering of the data, uncertainty management, efficient data storing, and temporal query execution. This research activity is a part of a research project named Assess and Management of RFID Data for the Monitoring of Outside Space. Here is the complete architecture of the proposed RFID data management system, which address and cater of the before mentioned data management issues in RFID-based systems. It consisting of two modules. First module for the data acquisition, online filtering, and uncertainty management, and the second one for the data storage and the query processing. Now I will explain the working of the first module, which is for the data acquisition, online filtering, and uncertainty management. This module is basically based on the probabilistic model. Actually, we build a model of the data, and it used the raw reading as an input to that model, which is known as the hidden Markov model. HMM is a temporal graphical model which is used to infer the hidden state based on the sequence of the observation. Generally, HMM consisting of the 5 parameters, which are the number of states, second observations, third initial state probabilities, fourth transition probabilities, that the probability of moving from one state to the other, and the observation probability, that is the probability of a specific observation on a given state. In order to learn the observation probability for the HMM, we have to train the system. For this purpose, we have used a popular statistical method known as the maximum likelihood estimation. The goal of MLE is the given training data, it will estimate the values of the parameter that will maximize the likelihood of observing that data. MLE gives us the joint probability distribution. By using the Bayes theorem, we can calculate the conditional probability distribution. For MLE, we have integrated a statistical package named Gretel in our prototype. It has lots of other useful statistical methods that we can use later on in our system. The ultimate goal of designing this stochastic process by using the HMM is to do the inference. The inference is a task to obtain the posterior distribution over the hidden states given the observed values. Here is the block diagram, and we have chosen inference algorithm named particle filtering for performing this inferencing task in our system. Here is the block diagram for the particle filtering. At the first step, the creation of the particles, and these particles are actually the representation about the guesses of the hidden states. Then we give transition to those particles on the basis of the transition probability, and this phase is known as the prediction. Now the particles are on new transited states, and upon receiving the observation, we update the particles by giving them weights from the observation probability, which we have calculated from the MLE, and this phase is known as the filtering. Resample the particles which are being updated during the filtering phase, and finally we can calculate the marginal probability for each of the state. The output of our first module is the inferred probabilistic tuple, and we need to store them in such a way that we can process and query them efficiently. And this thing comes under the second module of our system, which is the data storage and the query processing. For this purpose, we have integrated a probabilistic temporal database named MayBMS in our prototype. It's an open source probabilistic database, and it's an extension of a famous DBMS Postgres. It has the following feature. It supports the efficient data representation and storage mechanism. It has expressive query language very similar to the SQL, and it has several optimization techniques for the query processing. Here are some sample queries that can be used to query our data management system. For example, who was in the location 1 at the first minute, where was the Bob in the last minute, and so as the others. Finally, conclusion and the future work. In this work, we have proposed a probabilistic solution for RFID data management and implemented a prototype which consisting of 2 modules. First module for the data acquisition based on the temporal graphical model known as hidden Markov model, and the second module for the data storage and query processing, including an appropriate probabilistic database that allows the efficient storage of process stream coming from the first module, that is for the data acquisition. In the future, we will focus on the second module of our system for the efficient storage of the process stream, and we will propose and develop a robust solution that allow the efficient storage of the data in DBMS in an aggregated form without the loss of the information. Thank you very much. Any questions?